Did everyone get a copy of the choice sum before I put these away? Okay, today's lesson is going to be called Application of Cross-Product. Maybe I should do one quick warm-up here before we continue to make sure that everyone understands this. Okay, I'm going to today be cruel. Okay, and I think we're going to do it that, although Michael, you're sitting there, you're not going to get the answer though, okay? So what we're going to do is this. Oh, this is nice. We're going to let the first row answer the first part of the question, then the second row answer the second part of the question, and then the third row. So lucky you guys. Okay, three of you guys. Okay, you guys are the three first in the class. No apologies. All right, so don't worry about it. Okay, so we'll do this to give people a chance. If you guys, I can snub you guys for a little bit. Okay. So can I get someone in the front row to tell me, please, how I find the dot product? What does U dot V equal, please? Someone in the front row. Not Cartesian, the non-Cartesian version of it, please. Yeah. So this is magnitude U. Magnitude V cos theta. What can I, how does that help me? What can I use that for? Lots of things, okay? Well, I'll help you. Okay, projections, definitely. We'll talk about those today. Solving for thetas and cosine are sort of the two biggest ones right now for us, okay? When I'm dotting Cartesian vectors, how do you dot Cartesian vectors? Someone in the second row. Let's dot Cartesian vectors. Let's write this in English. What do you do? Oh my goodness, the second one is going to cause problems. Evan, how do you dot Cartesian vectors? Yeah. Yeah. Okay. So for Cartesian, you're going to multiply the coordinates and then add them up. And I'll do an example here to make sure life is good. Is that clear enough? For that, right? So x multiplies by x, y multiplies by y, z multiplies by z, and then you sum them up there. Okay. This is a scalar. Okay, this is a number, not a vector. Can someone in the back row, and you guys can skip the next round, tell me what U cross V is for non-Cartesian vectors? Someone in the back row. If you need to look at your notes, feel free. This is going to take a long time. Very good. Yeah. Very good. Okay, so that will be a vector quantity, okay, because of the n hat. What n hat, can somebody tell me in the class, you don't be in the front row, but anyone, what does n hat mean again? Go ahead. Very good. It's a unit vector. I should probably write that on the board because that's a good comment. Okay. So n hat is a unit vector. What does a unit vector mean again? Yeah, well, sort of. Go ahead. Magnitude of 1. That's what unit means. Look at this. It's a 1. Okay. And it's going to be perpendicular to both U and V. Okay. Sorry. Question or? Yeah. Yes. Yes. Right. You're going to get a vector. Good. So let's pretend this is like 13 or whatever. Okay. Right. 13 then times whatever that vector is going to be. Okay. How do I do a Cartesian cross-product? Someone in the front row. This is what we did yesterday. IJK. That's good enough for now. I'll do an example right now. So for a Cartesian cross-product. IJK, and we'll go through those right now to make sure life is good. If you know a box method or something, stick with the box method, all right? Now, what I did right now is called study notes for a test, okay? What I recommend you guys do for your test, not only in this course, but in all your courses, it wouldn't hurt like to sort of explain to yourself what every equation is done and what it's used for, okay? When I see people, I know it's hard, you're thinking about the March break, I get it. When you're saying, is it sine or cos? Like that's a little bit of a problem. Okay, I know it's because we've gone through fairly quickly, right? But by the time the test comes, these have got to be like automatic for that right there. I'm going to do a quick example of crossing from yesterday. just to make sure that this is back in the front of your brain. Example 1 says vector u is equal to 2, 0, negative 3. Vector v is equal to 3, 1, and negative 2. Find u cross v. Okay, so everyone take the next 3 minutes of your lives and do this one, please. This should be straightforward. Okay, this should just be go, go, go. If you weren't here yesterday and that person that wasn't here is still not here, so please volunteer. Other than Evan, you're out since he's volunteered a lot. Somebody else here, please be brave. Tell me what to do. Go ahead. Yeah, what do you do after that? Okay, so we're going to do 2, 0, negative 3, 2, 0, negative 3. Great. Wonderful. All right, someone in the back row. Actually, I'll stop. I'll you guys go. Somebody in the back row, what do we do next? Now that I've got this. No, go.
Line from 0 to negative 2.
Okay. Yes, that's correct. Technically, it's actually touching I as well too. So it's saying here, it's like I times 0 times 2. That's the thing, okay? And then j times this, and then k times this. And then we're going to go the other way with negatives. Green. Okay, can I get a brave soul from the front to do some multiplying for me, please, and do the reds? Let's go to the front row. Arden, wonderful, go.
0 I.
Yeah.
Minus 9j.
Great.
Plus 2k.
Great.
Plus 3i.
What's that? You good? Plus 3i?
Plus 4j plus 0k.
Okay. Now, can everyone close your eyes for 1 sec so no one sees each other? Close your eyes for a sec, text for you too. Please raise your hand if you're not clear what just happened there. Okay. Michael? Did you see what happened there? Okay. Okay. Good. Okay, everyone can open their eyes now. Okay. All right. Can I get someone now to in the second row? Thank you, Arden. Can I get someone in the second row to finish this one up for me, please? Okay. Can I get someone, please, in the second row? Jeff, go.
That's 3i minus 5j.
Great. And that's technically going to be 3, negative 5, and 2. So the question, everyone was asking questions about why it's not x, y, z, and all that. Because remember, like 3i is going to be like the x coordinate, right, of the Cartesian vector. J is going to be the y, and k is going to be the z. All right. So just so you're aware, when you get to university and you take linear systems or whatever, wonderful deep math in university, could I potentially have a 10-dimensional vector? 4-dimensional vector, 5, 6, 7. Like this vector can go on theoretically forever, right? So this happens to be 3 dimensions, x, y, z. But you can get more and more and more and deeper and deeper and deeper. Now I know you're saying to yourself, well, why would I ever need that? Somewhere back in like the 1700s, they were dealing with proofs with like x to the 5 equations. People thought, when would I ever deal with that? Basically, what happened was 500 years later, when they made like those phones that you're using right now, basically they're using the mathematics that was developed 500 years ago out for that. If that doesn't blow your mind, nothing does. So the point is, the application I'm trying to say for that is, you may say to yourself, when you get to university, you're dealing with some of this deep stuff, saying, when is this math ever going to be useful? Maybe right now it's not, but down the way with computing, computing is using all this stuff. Okay. All right. That said, I'm going to do one more question because we didn't cover this yesterday. I'm going to put a star beside this. It says I'm going to use if. Let's use P and Q. P equals 5, 6, negative 3. Q equals 0, negative 2, 1. Find n hat. Okay. Now, this is a little bit more tricky here right now. Where did I stop? Back row? Where did I stop? I stop middle row. It opens up to anyone here right now, not just back row, but you guys can take it if you want to. What is n hat again? Good. What else is it other than the unit vector? Good. So what it's going to be is it's going to be a vector.
P cross Q or Q cross P?
Oh, we'll go P cross Q, okay? So we're gonna say it's gonna be a vector perpendicular to both. What else is it gonna be? What's that? If it's perpendicular, what else is special with n, other than perpendicular to both?
Up and down.
Yeah, up and down, good. What else though, is one other thing? It is up and down, yes, it can either be this or this, that's fine. What else is it? Sorry? Nope.
Starts at the origin.
You're missing it. Tyler, I know you've done this because you saw it on your last test. What else do we know? What else do you know about n hat? It's a vector perpendicular to both. What else is it? Good? Wonderful. Somebody, oh, you don't really, I'm not being clear. Thank you, Michael. Okay, so this is how this question is going to change. Okay, so whether you do, sorry about that. So the idea is here for this, whether you use P cross Q or Q cross P, it's going to give you a vector that looks something like this. How would I make this have a magnitude of 1? Oh, I gotta slow down here. You guys are all tremendously intelligent people, okay? Let's say, for instance, that I'm going to walk across the classroom 5 meters. That's 5 meters. Going backwards now. Okay. If I only want to walk 1 meter, how do I relate that to 5 meters? Divided by 5. Okay. So what I'm going to do is I'm going to find the magnitude. So I'm going to find P cross Q, which are what you guys are going to do. Then I'm going to find the magnitude of P cross Q, and then divide. So it's going to basically be n hat, oops, n hat, sorry, is basically going to be P cross Q divided by magnitude of P cross Q. Okay, so let's say we know this vector has got a magnitude of 4, let's say. Right, we want the magnitude of 1, you're just going to divide each coordinate by 4. Okay, so you're going to find the P dot cross Q as the numerator. It's going to give you your dimension, or sort of give you the direction of it. The magnitude is going to be at the bottom. We want to have a magnitude of 1, right? So that's going to be that. So what I'd like you to do is to do that for me right now. These are going to be a mess. Okay, do your best right now. Yes?
The sine theta disappeared because it's 1
Sort of, okay. I'm just using logic. I guess you could say that, yes. Okay, I'm just using logic here. That's all I'm doing here for right now. Other reason it's disappearing is because we're dealing with Cartesian, right? So we don't know the angle sort of between them here. All right, so I'm using, I don't want to say it, I'm using logic here. That's what I'm using, okay, rather than the equation to rearrange. Would it be perfect? You confuse me now. I'm going to pause while I... Right, but remember that the theta is the angle between P and Q, though, right?
Yeah.
Okay, so P and Q, the angle between P and Q isn't 59, right? All right, stick with this, start with this. Okay, and then I'll try and answer Nate's question here in a second here. Oh, 13 minutes.